All right, folks, now we're ready for normal distributions. Example 4, part A. We're told that the life expectancies in the United States are normally distributed. That's what allows us to draw our bell curve. And the mean is 78 years, and the standard deviation is 7.2 years. So we know that the mean, it's normally distributed, and the mean of 78 years would go right there in the middle. So in part A, they want us to find the probability that a randomly selected U.S. citizen would live to be more than 67 years old. Well, first of all, 67 would be below the mean. And when we say more than 67, we're talking about to the right of. So this would be the picture of that particular area, and that's the probability we're looking for. So the variable is life expectancy, and more than 67 would translate into greater than 67. So there would be our general normal setup with that, with the picture and everything. Now, again, in order for us to be able to use our table, we've got to standardize things. So again, I would suggest that we put the standard normal bell curve underneath here. Again, that would be the bell curve with 0 in the middle that we worked with on assignment number 16. And we would have the same looking picture. We have a z-score below the mean, just like that age is below the mean. And we would want to standardize the score. So the variable x will transition into z. And we want to change that 67 years into a z-score. And again, this would be our thing that we use to translate that. Z equals x minus mu over sigma. So we will apply that to this situation. X would be the age of 67. Mu would be the 78. And sigma is the 7.2 years. All right, and so when you do the math on that with your calculator, and I want to remind you that you would round this to 2 decimal places because the table we're about to use will round things to 2 decimal places. So that comes out to be negative 1.53, which makes sense because, again, if you're below the mean, you're going to have a negative z-score. So this would be the corresponding picture with the standard normal, and this now becomes assignment 16, basically. So now we can go and use the table here to look this area up. So if we go look up the 1.53 on the table here in a minute, just remember it will always give us this middle region from here to the middle. So we'll go look that up. 1.5 out here in this first column, and 3 over, or 1.5 in that row, and then 3 in this column, and those intersect at 0.4370. You have that table in front of you. It was sent to you, and now I forgot. I walked too far away. 0.4370 would be that particular middle sliver. And then again, according to the logic that we established on assignment 16, we would also want to add on that entire upper half of the bell curve, 0.5. So when we take that middle sliver, 0.4370, and that upper half of the bell curve and add them together, that adds up to 0.9370. And I really don't care terribly how you would report the final answer here. It did say probability, so technically a probability could be left in decimal form, 0.9370. And if you wanted to, this is optional in my opinion, if you wanted to change that to a percentage by moving the decimal 2 places, what we would be able to say is approximately 93.7% of the U.S. population will live to be older than 67. So there you go, that's example 4, part A.